Hello, Luke. Welcome to lesson 27. So today we're going to be talking about more distributive property, and we will also take a look at some decimal equations. And I apologize if my voice is a little bit off today. I appear to be coming down with a cold, so I will try not to sneeze all over you here, figuratively, of course. So anyway, let's go ahead and get started. We're going to begin by just reviewing what the distributive property is. So you recall the distributive property is where we distribute a term through a set of parentheses. So if I have something that looks like this, right? And I say use the distributive property. You recall that all that means is we take this outside factor here and we are multiplying it through by the first term, and then we multiply it by the second term, right? So we take this 4y and we multiply that by the 3x, and then we add, well, I should say, we add the 4y times the 3m. So we have 4y times 3m, right? And again, I got those by simply taking this 4y and multiplying it by the 3x, and taking the 4y again and multiplying it by the positive 3m, which is going to give me a positive answer. That's where this plus sign came from, a 4y times 3m. Right? So then it's just a matter of multiplying the coefficients. So the 4 times 3 is going to give me a 12. I can't multiply the x and the y. I don't know what they are, so we're just going to write xy. And then we have plus, again, the 4 times 3 is 12. And this time we have the my, right? And that's really as far as we've taken the distributive property right there. That's what all of your seat work assignments have looked like. So today we're going to take this just one little step further. It's really not complicated. It's really not involving anything new, but there is a little bit more work involved. So an example, let's say I have 3z times az plus, let's go with bz squared plus mz. Okay, something like this. And I'm being told to multiply, to expand, to use the distributive property to multiply this out. So to do that, again, we're just taking this 3z. It's all revolving around this factor on the outside. And we're going to start by multiplying that through by the az. So I have the 3z times the az, right? And then I'm going to take that same 3z, only I'm going to multiply it now by the next term, which is this positive bz squared. And this is a positive also. So a positive times a positive, that's going to give me a positive. And then I have the 3z, and that's being multiplied by the bz squared, right? And then we can take that final step and take the 3z one more time, and we're multiplying it by the next term, which is this positive mz, right? And again, we have a positive times a positive, so we know this is going to be a positive. And then we have the 3z times the mz. Okay, so far it's exactly what we've done before, as in over at this problem, right? The difference here is that now, once we've done that multiplication, we have to actually look through all these factors, and sometimes we will see that there are things that we can actually combine or multiply in these terms. So if we look at that first term, 3zaz, we'll notice that we have a z being multiplied by a z here. All right. Now remember, when we're multiplying variables, and they are like variables, they're the same variable, we multiply them by adding the exponents, right? So this would be equivalent to 3z squared, right? And then the a on the end, if I wish. Or I could have put the a first, I suppose, and kept it in alphabetical order, but that's the way I wrote it this time. So z squared a, right? And the reason we got that is because we have the z to the first and z to the first. So 1 plus 1 is 2, right? So we have z squared. All right. So then let's look at the next term here. We have plus 3zbz squared. And here, again, we have some z's that we can actually multiply. We have this z and this z. So we have a positive 3. Now, again, if we add the exponents, we'll end up with z to the first times z to the second, which is z to the third. And then, of course, we still have the b, right? And then finally, that last term there, we have a plus 3. And again, we have these two z's. So adding the exponents again, we're going to end up with z squared m, right? And it's at this point where we can look at this and see if there are any like terms. And lo and behold, they are not like terms. This one has a z squared. This one also has a z squared, but this one has an a and this one has an m, so we can't add those together. This one has a z to the third, a z cubed, so that doesn't match either one. So there aren't any like terms that we can add in here. Therefore, this would be our final expansion using distributive property, right? So you can see there really isn't a whole lot different here. All we're doing is recognizing that when we use the distributive property, sometimes there is some multiplication that can be done inside the terms to simplify them further or to combine them further. All right. So let's try just a couple of these. I might just pull a couple from the book here that are maybe just a shade more complex and see how you do. So if I have we'll go back to my black here. So if we have 4xy, and then we're multiplying that by, well, actually, let's make that 4xy to the cubed. How's that? And then we've got x to the fourth y minus 5x. There we go. All right. So we'll do this one together, and then the next one you can do on your own first, and then we'll see how you did. So here, we're again taking, oh, sorry about that. We're taking the 4xy cubed and we're multiplying that through the parentheses here. So 4xy to the third, x to the fourth y. Now, maybe for this one, I'll go ahead and write it out. But ideally, if you're very careful, you should be able to do these in your head, at least eventually. But for right now, we'll write that out. So that's going to be 4xy to the third times, and I'll just maybe throw that multiplication sign in there just so you can see where I'm getting these. This is the 4xy to the third, and then I have x to the fourth y that I'm multiplying that by, right? And then I have my next term here. In my next term, I have, again, think of, try to get the sign figured out. So I have a positive times a negative. And again, we're taking this and multiplying it through by this next term. We have this positive times the negative. That's going to give us a negative, right? And then we have the 4xy again, and we're multiplying that by the 5x, right? All right, now we can go ahead and just kind of, combine some of these factors here. So to begin with, we'll go back to our blue. We have 4xy to the third, x to the fourth. Now, if we look at that, we recognize that we have an x here and an x here. So we can combine those. So if we add the exponents, because again, this is all multiplication. So we add the exponents, x to the first times x to the fourth. That's going to give me x to the fifth, right? And y to the third times a y to the first, right? We have some y's here too. That's going to give me y to the fourth, right? And now I've simplified that as far as possible. So now I can go ahead and go on to the next one here and go minus. Now here I have a 4 times a 5. Well, I can combine those. That's going to be 20. And then I've got an x times another x. Well, that's going to give me an x squared. And then I have a y. There aren't any other y's, so we just have a y. And we end up with 4x to the fifth, y to the fourth, minus 20x squared times y, right? And there's nothing else that we can do here. So that would be our solution for this problem. All right? So hopefully that makes sense to you. Let's have you try one here. So I'm going to write out the problem, and then you can pause the video and try it yourself. So the problem will be AY minus 4y to the fifth. And we'll multiply that by 2x squared. And notice I'm just changing things up here a bit. I'm just writing the outside factor to the right of the parentheses instead of to the left, just to try to confuse you. Hopefully that didn't, though. You hopefully recognize that it's still just multiplication here, and we're still going to distribute that through. So go ahead and maybe try that on a piece of scratch paper, and then we'll do it together. All right, so how did you do? We've got our outside factor. We're multiplying that through. So we have a 2x squared y times the ay. Now I'm going to start to kind of do some of these in my head. The coefficients, there's only one, and that's the 2. So 2 times the invisible 1 over here is just going to be a 2. And then we have an x squared. There aren't any x's over here, so we still have an x squared. And then we have a y, and there is another y. So a y times a y, add the exponents. That's going to give me a y squared, right? And then that's everything over on this factor. But on the inside, I still have this a that I didn't write down. So I know I've got that a. So I've got 2x squared y times ay. The y's combined to get the y squared, and the rest is just rewriting 2x squared y squared a. All right. Now here I'm going to recognize that by taking this 2x squared y and multiplying it by my next term here, I'm going to have a negative because this is positive. So a positive times a negative is a negative. And now I've got the 2 times the 4, which is in fact 8. I can take care of that. X squared, well, it's all by itself. There aren't any other x's. The y, there is actually a y to the fifth. So if I add the exponents there, I get y to the sixth, right? And that's everything accounted for. I've accounted for this one. I've accounted for this one. I've accounted for the 2. I've accounted for the 4, and I've accounted for the y fifth to the fifth. So that is going to be my solution right there. Now, it's always good to just double check. Sometimes you might find that there are like terms in here. And in this case, we look at it and we go, nope, there aren't any. So this would be our solution. And maybe just to point this out, just in case you did it the opposite way, you certainly could have distributed that through differently. I actually kind of went, from the left and worked my way to the right. You could have distributed it through by multiplying it first by the 4y to the fifth, and then multiplying it by the a to the a times y. That's fine. It would just give you a solution that's the opposite of what this one is, as far as what's written first. So I would have, a negative 8x squared y to the sixth plus a 2x squared y squared a. This would also be an acceptable answer. There's nothing wrong with that. You just multiplied it through in a different order. All right, and the order doesn't matter in addition. Remember, addition is commutative. We can reverse things and go back and forth. It's not a problem. So we can switch these two around and still have an acceptable answer. All right, so let's try, excuse me, one more here, just for giggles. Let's go with, let's do a 3x p to the third p to the fifth minus x squared p to the eighth. Yeah, let's do that one. So go ahead and pause the video and give this one a try, and then we'll do it together. All right, let's give it a whirl. So we have 3x p to the third, and we are multiplying that through. So we're multiplying it by the p to the fifth first here. And you can recognize right away that it's 3 times 1. There aren't any other coefficients. X times, there aren't any other x's, so it's still an x. P to the third times p to the fifth. Well, that we would add the exponents to get p to the eighth, and that's accounted for everything. Everything in here has been accounted for. We did the x, we did the p to the third, and we did the 3. So that's everything there. Then we can go to our next term, multiplying this through. We have, again, no coefficients, but we do need to recognize that this is a positive 3 and this is a negative, you might say even a negative 1, just invisible right there, right? So positive 3 times a negative 1, well, that's going to give me the negative 3. And then we have an x multiplied by an x squared. That's going to give me an x to the third. And then we have a p to the third times p to the eighth. Well, that'll give me p to the 11th. And then always just look back, make sure you didn't leave something out. And we did the x squared, we did the p to the eighth, we did the x and the p's, and we did the 3. So we got it all covered there. So therefore, that is our final answer. And again, there isn't anything else we can do here. There's no other simplifications that can be done. So there is where we will stop. That is our final solution. All right. So hopefully these make sense to you, Luke. They're really not difficult. They're just combining two things that we've already learned. Adding exponents when we're multiplying variables, and using the distributive property. All right. So the next section of our lesson today is going to deal with decimals. So let's delve into that next here. And the issue is equations that have decimals in it. So if I have an equation that looks like this, 0.4m, minus 0.04 equals 0.003, okay? Decimals are just numbers, but they're just not nice numbers. And so when we're dealing with decimals in equations, the mathematics behind it can get just a little bit complicated in the sense that it'll be easy to make mistakes. So for example, maybe the first thing you would recognize that you'd want to do here to get m by itself would be to add the 0.04, right? So you're going to say, oh, I'm going to add 0.04 to this side, add 0.04 to this side, and then work that out. But because we're dealing with decimals, whenever we're adding decimals, we do have to make sure that the decimals are in the same position when we add decimals. So that actually is a 0.003 plus a 0.04. And then just to kind of block this all off so they have the same number of digits, we'll throw a 0 on the end there. That won't change the value, right? But that's what we have to do because we have to keep these decimals in line. So adding these just becomes a little bit more work because you have to, set your decimals up so that they are in line with each other before you do the adding. It's more difficult to do it in your head. All right. And then the next step here would be to divide, right? So we're going to divide out this 0.4. But again, division is just a shade more complicated when we have division by decimals. So here you would have to actually write the 0.043 and you divide this by the 0.4. And remember, the first step is to move that decimal over, in this case, one position. So put the decimal there. And then we can divide normally. 4 can go into 0.4, which is just 4, once. And we can subtract and bring down the 3. And then it can go into it 0 times. 0 times 4 is 0, which is 3. We can then annex another 0 and bring that 0 down. 4 can go into 30, 7 times, 28, with a remainder of 2. And then we'd have to annex another 0 and bring that down. And now we've got 20. 4 can go into 25 times. And then 5 times 4. Oh, we made it. Is 20. All right. So we end up with m is equal to 0.1075, right? 0.1075. So again, because we're dealing with decimals, it's just a little bit more work. So what we're going to look at today is how can we kind of figure out a way to maybe make these a little bit more palatable, make them just a little bit easier to work with, right? So what we'll do is we'll take that same problem, maybe we'll do it in a different color here. So if we have 0.4m minus 0.04 equals 0.003, okay. And the first step that I'm going to do here to make it a little bit easier is to try to eliminate the decimals. And we're going to get rid of them by using the multiplication rule for equations, which says that I can multiply this side by anything I want, so long as I multiply it by this side, and the solution for m will be the same. All right. So knowing that, we're going to use that to our advantage and ask ourselves, what could we multiply everything by that would eliminate all decimals? And what you need to do is you need to remember back on kind of how decimals work. If I have, let's say, 0.23, what happens if I multiply this number by 10? Do you recall? If I multiply this by 10, all that happens is the decimal place moves over one position to the right. So if I multiply this 0.23 by 10, I would get 2.3, right? If I, I'll just put multiply by 10. If I multiply by another 10, I would move it over one more time, and I would get 23.0, which is the same thing as just 23, right? I can drop that 0. If I were to multiply it by another 10, what happens? Well, this 23 has an invisible decimal right here, right? And if I move that decimal over one position, well, that means I have to fill that position with a 0, so I end up with 230. So if I multiply this by 10 again, I'm going to get 230. And if I multiply it by 10 again, I'm going to get 2,300. And as I multiply these by 10s, all I'm doing is moving that decimal place one position further down and thus adding a 0 to the end of the number, right? So that's what happens when we multiply things by 10, all right? In fact, that's what happens when we multiply things by 10 or 100 or 1,000 or 10,000. The difference is just the number of positions we move the decimal. So if I take that 0.23 and multiply it by 100, what happens now? Now, instead of the decimal only moving one position to the right, it's going to move two positions, right? So if I take 0.23 and multiply it by 100, this will move twice, and we end up with 23.0, right? If I multiply that by 100 again, we're going to move another two positions. So we'll go 1, 2. We have to add a 0 here. So we end up with 2,300 or 2,300, right? So you can see when we multiply things by 100, all we do is move the decimal place two positions to the right. And this should really be a review for you. I mean, you should have learned this years ago as well, but just as kind of a refresher. When we're multiplying a number that contains a 1 and then a bunch of zeros, such as 10 or 100 or 1,000, all we do is move the decimal place in the other factor the same number of places as the number of zeros that we have in the 10 or the 100 or the 1,000. So in this case, there's only one 0, we move one position. Here there are two zeros, we move two positions. If we multiplied by 1,000, there are three zeros, we would move three positions, and so on and so forth, right? So kind of keeping that in mind, what could we do over here? What number could we multiply this whole equation by so that we would eliminate the decimal points? All right, so the idea is we're trying to get these decimals to move until they move far enough away that we have whole numbers instead of decimal numbers that we're looking at. All right, and if we look at these, I would maybe ask you which one of these coefficients is the smallest. And you may recall that in decimals, it's a little counterintuitive, right? So if I'm asking for which one is the smallest, you're actually going to give me the one with the most number of digits past the decimal, right? So the smallest number here is actually this 0.003, because remember that stands for 3 1,000ths. That's what that decimal means. This one would stand for 4 100ths, right? And this one would stand for 4 tenths, right? So the smallest number is actually the 3 1,000ths, because we're dividing the pie up into 1,000 little pieces. We're dividing it up into very, 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 very small pieces compared to only 100 pieces, or even less still, 10 pieces, all right? So bottom line, we're going to look at our smallest decimal, which in this case is this one, because it has the most number of digits, okay, past the decimal point. And to get this decimal point then to move 3 places, 1, 2, and 3, we want to get it right here. If we want it to move 3 places, well then we're going to have to multiply this by a 1 with 3 zeros after it. Remember what I said? The number of zeros indicates how many places you're going to move it. So if I multiply it by a number that has 3 zeros, I'm going to be moving this 3 positions. All right? So I'm going to actually multiply this whole equation by 1,000. All right? So I'm going to multiply, for example, this side by 1,000. And I'm also going to multiply this one by 1,000. Okay? Now this is where distributive property comes back into play. All right? And that's why learning these two things today makes sense. Here, I took this whole side and multiplied it by 1,000. I can't just take part of the side. I have to take the whole side and multiply it by 1,000. So if I do that, then I need to actually distribute this 1,000 through using, ding, 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 distributive property. Okay, so 1,000 times 0.4m, well, 1,000 times 4 is going to be what? Well, we're going to move the decimal point 3 positions. So we'll move it once and then twice and then 3 times. So we have to add 2 zeros there, right? So that's going to be a 400m, right? Because we moved that decimal 1, 2, 3 positions. Okay, minus, now we need to move the decimal 3 positions again. So we're going to pop on another 0 there. And you end up with, 0.40, but these ones would just disappear. 0.40, that's the same thing as 40, right? So we can just write that as 40, okay? And then over here we have 0.003. Well, by design, we're going to move that 3 places over, and we're just going to end up with the 3, right? So notice what happened here. We actually got rid of all of our decimals, all right? Which will make this equation that much easier to actually solve. All right, so here it's the same thing that we've been doing all along. We're going to add 40 to both sides. And we're going to end up with the 43 over on this side. This will cross out. You have 400m is equal to 43. Now we're going to divide by 400. These will cross out, and you end up with an m equals 43 over 400. Now, if you wanted to take the time to do it, you could certainly take 43 and divide it by 400. And if you did that, you'd have to annex some decimals here, right, to do that. But if you did that, you would, in fact, end up with 0.1075. 0.1075 and 43/400ths are the same thing. One's just a decimal, the other is a fraction. All right, so you are perfectly legitimate in leaving this as 43 over 400. Okay? All right, so with all of that being said, let's just try a couple of these and make sure that you've got the general idea here. So if I have 0.08 x minus 0.01, well, actually we'll just make that 0.1. equals 16.7. All right, go ahead and pause the video and try to solve this by first eliminating the decimals and then solving the equation. All right, so let's see how you did. Let's first start by multiplying out the decimals. And to do that, we need to figure out what number we're going to multiply this equation by. So we looked for our smallest decimal, which would mean which one has the most number of digits after the decimal point. So here we have 2 digits past the decimal point. This one only has 1. This one has 3 digits, but only one of them is past the decimal point. So we count that as just 1 position. So this one actually has 2 positions of decimals. So this one is the smallest. So we're going to need to move this decimal point twice, which means we need 2 zeros in the number that we're multiplying this by. And therefore, we're going to multiply both sides by 100, right? And I know you got that. right? I have confidence that you got that on your scratch paper. So now we have the 100 times 0.08x. That's going to move this over twice, right? And we're going to end up with 8x. Now we have to distribute this through. So we did it there. Now we need to do it to this one. This is a negative. This is a positive. Positive times a negative is going to give us a negative, right? Then we have the 100 times 0.1. Well, we need to move that decimal point twice. So once, twice, it's going to be a 10. You follow me? All right. And then on the other side, we need to move this decimal twice as well. So we're going to end up with 1/6 and then the 7 and then the 0. 1,670. So the numbers are a little bit bigger, but we did succeed in getting rid of the decimals. All right. Now we can solve this as usual. So we add our 10 to both sides, and these will cross out. So we have 8x equals 1680, right? And then we can divide both sides by the 8, and we get, well, what's 1680 divided by 8? Well, it's going to be a 2, which will give us the 16, right? And then it's going to be a 1 to get the 8, and then, of course, a 0. So it's going to be 210, right? So x equals 210. Didn't that work out nicely? All right? That is how we make these decimal problems just a little bit simpler. So we'll try one more, and then we'll be done for the day. So we have 0.7m plus 0.6m equals 3.4. Okay, let's go ahead and work this one out. And again, do it yourself first, and then we'll try it together. All right, so hopefully you had no trouble with this one, but if you did, that's all right. We're going through it. So the first thing maybe let's start by getting rid of the decimals. Let's just keep that as our standard step here when we see decimals. So looking at that, we would use, count up the number of places, and actually they all just have one digit. So we're going to multiply everything by a 10. That makes this easy. So we multiply everything by the 10 so that we have to move the decimal point once, which would then get rid of all of our decimals. So 10 times 0.7, we move it once. We have a 7m. Plus 10 times 0.6 is going to be a 6m. Equals the 3.4 times 10. Well, we move it once again. We get 34, right? Oh, this is looking nice and easy at this point. 7m plus 6m. Now, notice these are like terms, right? So we can combine these. 7m plus 6m, we add the coefficients, 13m, and just because we're still kind of, developing this, recall, we don't add the exponents. A lot of times people will make that mistake. They'll think, oh, 7m, plus 6m, well, that's going to be 13m squared. No. You only add the exponents when you are what? When you are multiplying, not when you are adding, right? When you add variables or terms, you add the coefficients. When you're multiplying, you not only multiply the coefficients, but then you also add the exponents. All right, so make sure you keep that straight in your head. Here we are just adding the coefficients. The variables do not change. Okay, so we have 13m equals 34. And then we can divide both sides by 13. All right, and we have m equals, well, let's see, 13. We can maybe make this into a mixed number just for the fun of it, since it's our last problem. So we're going to say this is going to be a 2, right, which is going to be an 8/13, if I did that right. So we have 2 and 8/13 as our mixed number, right? All right, and you could have, I suppose, left that as the 34/13. That would be acceptable as well. All right, very good. So hopefully that went well. Keep in mind what we've learned today. It's really nothing too terribly new. We've just kind of expanded on our knowledge of distributive property, and remember to combine those factors, multiply the factors that you can. the variables by adding the like terms. And then we've also talked about eliminating decimals from equations. And that's all based on knowing what number to multiply the equation by. All right. Very good. Well, we will stop here, and I will see you tomorrow.